discuss that is very, very important. Any part of the convection, okay, they may ask that one is the, this is one of the important questions as per the examination point of view, as per the research point of view, and I think you are very compatible in the subject of the fluid mechanics, I hope, okay. So simple, the terminology we are using from the fluid mechanics, okay, convection. Because why I'm taking the word the fluid mechanics here, the convection is happening only in the a fluid. Understand? It may be liquid or it may be gaseous. Hence, we are considering that one is the knowledge of the fluid mechanics. Okay, yeah, that's very, very important. That one is okay. So I hope you studied about the boundary layer in the fluid mechanics mechanism. Okay, so what is the concept of the boundary layer? We need to discuss in the today's section. And the concept of the boundary layer and what is the importance of the boundary layer in the analysis part of the any heat transfer equipment. Also, we should know about that one is in the today's class, we are going to discuss about the boundary layer. Suppose you consider, okay, so this is the plate here. So a leading edge of the plate here. So what it is in the diagram, and this is the this end is called as a trailing edge here. If the fluid, okay, flowing with the velocity u, if the fluid is flowing with the velocity u, and so this is the what is called as the first one is the laminar, okay, flow will be occurs, that means laminar flow will be occurs. So after the so laminar flow, one is called as a transition period or transition, that is the distance, the transition period or transition the layer, and other one is called as the third one is called as a turbulent boundary layer. Okay, laminar boundary layer, transition boundary layer, and turbulent boundary layer. So this the laminar boundary layer, transition boundary layer, turbulent boundary layer are very important in the formation of the boundary layer over the plate here. Okay. So this is the x-axis and y-axis. This is called as a plate here. Okay. Leading edge of the plate, and this one is called as a trailing edge of the plate. That one is. Okay. If the fluid is flowing with the velocity u, fluid is flowing with the velocity u, if the Reynolds number, okay, is less than 2300, so that is called as a laminar flow. As of you know, that one is if the Reynolds number is less than 2300, so that is called as a laminar flow. That one is. If the Reynolds number so more than that one is the 4000, then that is a flow is called as a turbulent flow. That one is. If the Reynolds number in between greater than the 2300, so and less than the 4000, that is called as a transition period, that is from laminar to the a turbulent when the fluid flowing over the plate. Understand? So this is the importance of the Reynolds number, that one is. Okay. So what is that one is? First we need to discuss about that the boundary layer here at the surface. Okay. At the surface, suppose that one is the this is the velocity profile here. Understand? The velocity profile when the a turbulent boundary layer, so turbulent flow is occurs. This is the a velocity profile when the a laminar flow occurs, that one is. Understand? Okay. So this delta is called as a boundary layer thickness here, that is. So this is the a parabolic in so nature, that is. Okay. So if the flow occurs above the surface, okay, means certain junction where the between the a fluid and this solid surface, that is called as a surface so that at the junction of solid and liquid, okay, where they contact, here there the shear stress, okay, that is tau naught, shear stress is more, understand? So that's the shear stress is a more. Due to the shear stress, the viscosity of the fluid will be more and more at the surface of the plate. Okay, if the viscosity of the fluid will be more, okay, viscosity, it is in between the liquid and the sun is a solid surface will be more, then the velocity is zero at the surface of the plate here. Understand? As the distance move, okay, as the distance move vertical or perpendicular to the plate, understand? Then velocity goes on increases, understand? Velocity goes on increases and viscosity goes on decreases, understand? Okay, where the velocity of the fluid reaches the mean stream velocity of the flow, mean stream, okay, mean stream velocity of the flow means that is where the velocity is the maximum, understand? Okay, so this is called as the 0.99 percentage of the u, means that is the initial velocity is u here, understand? Initial velocity is the u, where the velocity is approaches us to, so 0.99 percentage of the initial velocity, so that point, okay, that point which is distance from the, that is called as a surface of the plate to the this point, okay, that is distance is called as a boundary layer thickness, that one is. Up to that one means that up to that we are considering as a boundary layer, understand? We considering as a boundary layer. So I think you understood, okay? The distance, so which is perpendicular from the plate, the distance which is perpendicular from the plate, where the velocity of the, what is called as a fluid, approaches to the mainstream velocity. So up to that distance, we need to consider that one is called as a boundary layer thickness, which is denoted by delta here, which is denoted by the delta. So delta is called as a boundary layer thickness, which is perpendicular distances from the plate, where that is the velocity of the flow is equal to the 0.99 percentage of the mainstream velocity. Understand? Mainstream velocity. So that is called as a boundary layer thickness. Okay. So this is the where the, so suppose if we're taking the plate here, understand? Suppose if we're taking the plate here, uh, I'll discuss. Suppose if we are taking the plate here, understand? So this plate here, that is the flow will be occurs above this plate. Understand? If the flow occurs above this plate, the at this surfaces viscosity is more. Understand? If the viscosity more at this surfaces, velocity is zero at this surfaces. As the distance move on perpendicular to the plate, understand, as the distance move on from the perpendicular to the plate, so that's what is the velocity goes on increases and viscosity goes on decreases, that means the velocity where suppose if it is a point, velocity where it approaches the mainstream velocity, understand? So this distance is called as the boundary layer thickness, that one is, understand? Okay, the boundary layer thickness, okay, this is the distance perpendicular from the plate where the velocity of the flow approaches the mainstream velocity of the fluid. So that is called as a boundary layer thickness, that one is. Okay, so below the boundary layer thickness, below the boundary layer thickness, the what is called as viscosity goes on increases, understand? Above the boundary layer thickness, the velocity, what is called as a goes on increases, certain is. Okay, so that one is the above the boundary layer, the velocity will be the constant. Okay, above the boundary layer, further above the boundary layer, velocity becomes constant, that is called as the mainstream velocity. Understand that mainstream velocity, that one is below the boundary layer thickness. Okay, below the boundary layer thickness, the velocity decreases and viscosity increases, that one is. Understand? So this delta is cut as the what is called as a boundary layer thickness. Why you are considering that one is the boundary layer thickness here? That one is suppose I want to, so aeroplane. Okay, suppose the aeroplane, that one is. Understand? So if the air flowing or the body of the aeroplane, that one is, we need to analyze the what is called as the effect of the atmospheric conditions on the material of the aeroplane, that one is. Then using of the this boundary layer, where that one is the laminar flow occurs, where the turbulent flow will be occurs, that means. Understand? So what is the velocity of the fluid flow? So in that cases, for the analysis of the effect of the external forces on the aeroplane body, we need to analyze that one is. That in that cases, the concept of the boundary layer is very, very important. That one is. Understand? Okay, means what? So again, one of the important point here, that means the if it is a boundary layer thickness, it is a delta. Below this one, understand, below this one is laminar flow will be occurs, that one is. Understand? Laminar, more and more laminar flow will be occurs at completely at the surface of the plate. Okay, that is called as a laminar flow, that one is. Okay, so that one is above the plate, above the boundary layer thickness, that one is a turbulence will be occurs, that one is. Understand? Okay, the velocity, because above the boundary layer thickness, the velocity which is a constant, that means that is called as a mainstream velocity. Understand? So in that cases, we have to consider that one is the what is called as a not the laminar flow, that one is. Understand? Okay. So this is the concept of the what is called as the boundary layer thickness, that one is. Okay. If the so distance as the length of the plate so goes on increases, then transition period will be taking place. Okay, means that one is converting of the laminar flow into the turbulent flow. Understand? So that is if the so based on the that is the Reynolds number. Understand? If the Reynolds number is more than 2,300, okay, and less than 4,000, so that is called as a transition period. The fluid is converting from the laminar flow to the turbulent flow, that one is. Okay, as the flow is okay, as the distance is increasing, okay, as the length of the so here this figure, as the distance, okay, as the distance goes on increases, the boundary layer thickness is also increases. Okay, because in the turbulent, okay, boundary layer, okay, turbulent boundary layer will be different, laminar boundary layer will be different. As the distance of the plate, okay, as the distance of the plate is goes on increases, okay, if it is moved further, then what is called as the boundary layer thickness is also goes on increases, that one is. Understand? Because of so what is the because what is means the concept of the boundary layer, what we discussed, that is where it approaches the mainstream velocity 0.99 u. So that is called as the boundary layer thickness, that one is. Okay, so this is a very, very important, that one is. Okay, so here, so we are considering that one is the velocity u, then the leading edge, the fluid is flowing also above the plate here, and at the this one is the laminar flow, and this one is the transition period boundary layer, and this one is the turbulent boundary layer. So this one is the suppose this point, the what is called as the fluid velocity will approaches the 0.99 so percentage of the flow velocity, what is called as u. Okay, so that's a mainstream velocity, so which is at a particular distances. The distance of the from the plate, distance from the plate where the point where it approaches the 0.99% of the velocity mainstream pre-mainstream velocity. That distance is called as the a boundary layer thickness. If the fluid goes on move, then the what is called as the boundary layer thickness is also increases. Suppose in the case of the turbulent boundary layer, the boundary layer thickness will be increases. That one is okay. This is the case here. Some of the important points we discuss here in the what is called as boundary layer. Mathematically, the thickness of the boundary layer. Understand here. So that one is the thickness of the boundary layer. So here, mathematically, the thickness of the boundary layer can be defined as distance at which fluid flow attains the 99% of the pre-stream. The definition of the boundary layer is thickness of boundary layer can be defined as distance at which fluid flow attains 99% of the pre-stream velocity. Understand? Okay. Here, here that one is the distance. Okay, distance. The distance from the a plate where the fluid velocity reaches 0.99% of the mainstream pre-velocity of the fluid is called as the boundary layer thickness here. That one is below the boundary layer. Understand? Suppose this one is the below the boundary layer. So below the boundary layer, viscous effects are dominant. The below the boundary layer, viscous effects are the dominant because the shear stress will be more. Understand? Shear stress will be more. So if viscous effects so are dominant, and above the boundary layer, so okay, that one is the above the boundary layer. Okay, so this is the above the boundary layer. So above the boundary layer, what happens that one is the viscous effects are negligible because it already approaches. Understand? Because it already approaches the 0.99% of the 99% of the pre-stream velocity. That's why the viscous effects are negligible above the boundary layer. Okay, next point, the adjust velocity gradient. Understand, within the boundary layer, and velocity goes on increasing as we approach the boundary layer. The adjust velocity gradient. So here, okay, from the this is suppose this is the boundary layer delta here. So within this only there will be the adjust of the velocity gradient. Understand? Within the boundary layer, there will be exist of the velocity gradient. Understand? Within the boundary layer, and velocity goes on increasing as we approach the boundary layer. The velocity goes on increases until the boundary layer thickness. Understand? Until the boundary layer thickness. Below the boundary layer only the velocity gradient exists. That one is. So keep it in mind. Beyond the boundary layer, what happens? Okay, beyond the boundary layer means that is above this boundary layer. Okay, above this boundary layer, so the velocity gradient does not exist. Why? Because it already also approaches the 99% of the pre-stream velocity. Understand? Beyond the boundary layer, the velocity gradient does not exist, and velocity attains the a constant value called as the pre-stream velocity. Understand? Okay. So as from this points you discuss about that is, so only the velocity gradient exists below the boundary layer. That is above the boundary layer, the velocity gradient does not exist because it already approaches the 99% of the pre-stream velocity. Understand? Okay. Then what is called as the below the boundary layer, viscous effects is more. Understand? Viscous effect is more because of the so viscosity is so increases. Understand? Velocity is decreases. Understand? So if we go from the plate to the above, that one is the velocity is goes on increases up to the a thermal boundary. So that one is the boundary layer thickness, that one is. Understand? Okay. So do you have any doubt regarding that one is the a boundary layer thickness here?
No, sir.
Yes. And we can go to the what is the velocity boundary layer. So we got the a concept of the what is called as the a boundary layer. So that's a very important in the aeronautic domain, or it may be in the automotive domain. So where you need to analyze the fluid flow. Understand? Suppose if it is a IC engine is there, how to analyze that one is the fluid flow in the IC engine, that one is. Okay, because of that one is the flow which is occurred in the what is called as the pipe. Understand? So wall of the pipe, what is the velocity at the wall of the pipe? What is the viscosity of the wall of the pipe? Okay, based on that one is how to analyze the temperature distribution and how to analyze the velocity in the fluid, how this velocity and temperature and pressure it will affect the combustion phenomenon, that one is. Similarly, in the aeroplane, okay, so above the object, if the flow occurs above the object, what is the elasticity effect and temperature effect and pressure effect on the material or body of the aeroplane? So in that cases, the concept of the a boundary layer is very important, that is. Okay, so that's why. So we also already know about that is what is the concept of the a boundary layer and boundary layer thickness, that one is. Okay, now we are going to discuss about that velocity a boundary layer. Understand? So from this figure, we come to know about that one is the already we discussed about that one is this is the plate and the flow over the plate will be occurs here, that one is. So at a distance from the leading, this one is cut as a leading edge and this one is cut as the so a trailing edge, that one is, and this is the distance from so here XCR, understand XCR, that one is. Okay, so at the distance up to this one, the laminar boundary, we can call that one as the laminar boundary because of the a laminar flow occurs. After this one is there will be a transition region, that one is the Reynolds number is more than 2300, then there is a conversion of laminar flow to the a turbulent flow. Then after the if the Reynolds number reaches so 4000, then the whatever called as a turbulent flow, so that is called as a turbulent boundary layer. So already we discussed, and once again we need to discuss about what is the meaning of a velocity boundary layer here. Understand? So U naught is called as the initial velocity, or so velocity of the flow here, velocity of the flow. Okay, so at the starting here, the flow is laminar, and after that one is transition flow, and after that one is the turbulent flow. Understand? Suppose I know that one is the at the surfaces the viscosity of the fluid will be okay. Viscosity effect is more at the surface, that is at the junction of the fluid flow and solid plate here. Okay, whenever that one is the distance will be increases vertically, then viscosity is goes on decreases and velocity will be increases. That one is the where the velocity, understand, where the velocity is approaches the 99 percentage of the main pre-stream velocity, that is called as the velocity boundary layer thickness also. Okay, that is called as the velocity a boundary layer thickness. Suppose at this point the velocity which is approaches to the mainstream velocity u naught, understand. Okay, mainstream velocity u naught, this distance, okay, from the surface of the plate, understand, from the surface of the plate are called as the velocity boundary layer, that one is. Okay, that is called as the velocity boundary layer, that one is. And above this one is okay, above that one is a velocity boundary layer. above this one is there is no velocity gradient will be exist. Okay, then velocity will be constant. Velocity will be constant because it already approaches the what is called as the maximum velocity, which is equals to the what is called as the main pre-stream velocity of the fluid here. Okay, so this is called as the velocity boundary layer here. Okay, in case of the laminar boundary layer, okay, laminar flow. As the distance, okay, as the distance goes on increases, as long as the length of the plate will be increases, then the what is called as the so velocity boundary layer also increases. Suppose in the case of the turbulent boundary layer, so where the more velocity will be occurs, okay, pre-stream velocity will be more. In the turbulent, the velocity will be more. Velocity of the fluid will be more. In these cases, that's why the what is called as the velocity boundary layer is bigger than in the laminar flow. That one is understand. The velocity boundary layer in the turbulent flow will be bigger than the laminar flow. That one is because the velocity of the flow will be increases in the turbulent flow. That one is understand. Okay, so this is the velocity boundary layer concept. That one is what is the velocity boundary layer concept here. That one is the so as this is the plate and the flow over the plate will be occurs. That is the velocity will be maximum the distance which is whenever the distance will be moved from the away from the plate. Okay, move from the plate or away from the plate. That is okay, where it will be equal to the mainstream. Okay, pre-velocity of the fluid. Okay, where it's equal to the mainstream. So suppose that one is we are saying that one is in the pipe. Okay, suppose we are taking the example where the velocity will be maximum at the middle of the pipe will be maximum. So at the middle point to the surface of the inner surface of the pipe, okay, we consider that as the velocity boundary layer. Understand? Means certain is the maximum velocity will be occurs at the middle of the pipe. So from the middle of the pipe to the surface of the plate, we consider that one is the velocity boundary layer. That one is. Here the flow is above the plate. Understand? Here the flow is above the plate. So that one is the where the velocity is maximum. Means that it's equal to the main pre-stream velocity. So that at that point to the surface of the plate, that distance is called as the velocity boundary layer. That one is okay. So whatever the velocity gradient which is exists below the what is called as a velocity boundary layer, above that one is the velocity boundary layer. There will be not exist any velocity what is called as a gradient. That one is okay. So here some points we need to discuss about that. In general, when the fluid flows over the stationary surfaces, example the flat plate or bed of river or wall of the pipe, the fluid touching the surface is brought to rest. Why? Because of the shear stress. Understand? Fluid touching the surface is brought to rest. Okay, why? Because of the shear stress. Shear stress is more at the wall. So this is a very, very important. If the shear stress is a more at the wall, then viscosity dominant. Understand? If the viscosity is a dominant, then the velocity is equal to 0. Understand? So that's why I'm telling about the is at the plate, surface of the plate, viscosity is a more. Where the viscosity is the more, then the velocity is 0 here. As the distance move, which is perpendicular to the from the plate, understand, the viscosity goes on, decreases, and velocity increases. Where the particular find where the velocity of the flow is equal to the mainstream pre-velocity, that is distance. Okay, that is called as a boundary layer. Okay, that is called as a velocity boundary layer. That is understand. Okay, so this is the concept here. The region in which the flow adjusts from zero velocity at the wall to the maximum in the mainstream of the flow is termed as a boundary layer, as already we discussed. the concept of the boundary layer is the importance in all viscous fluid dynamics and also in the theory of heat transfer. Okay, so why is so we are saying that it is very important in the heat transfer, because of in the post convection the velocity is very important, because that one is the if the velocity is increases, that one is the heat transfer rate is also increases. Hence we need to discuss about the a concept of the what is called as the a velocity boundary layer. Also that one is the concept of the a boundary layer, and boundary layer is very important in the post convection. That's why. Okay, the basic characteristics of the laminar and turbulent boundary layer are shown in the developing flow of the flat plate. Okay, the stages of the formation of the boundary layer as shown here in this diagram. Okay, this turbulent boundary, we can call this one as a fully developed, understand, fully developed flow, because the velocity is more here, understand. So this one is called as a fully developed, that one is because of the velocity is more here, that one is understand in the turbulent flow. So all the concept means that one is what is a velocity boundary layer. So we discuss along with this figure, that one is discussed. Okay, is there any doubt here?
No, bro. No, sir.
Yeah, then
No, sir.
yes. So what is that one is the a thermal boundary layer. Understand? Thermal boundary layer. We need to, so already we discussed about that one is the, what is the concept of the velocity boundary layer? What is the concept of the simple concept of the boundary layer also that is? Then we need to discuss about the thermal boundary layer, because we are discussing about the heat transfer, convection heat transfer, post convection heat transfer. So we also very important that one is the thermal boundary layer. As we say that one is, okay, this is the plate, then the velocity will be increases, understand, that one is the velocity will be increases, which is the fluid, if you take in the vertical position, understand, okay, then if the approaches the pre-stream velocity, then that is called as a what is called as a velocity boundary layer. Like here also that means if the plate here, the fluid is flowing, okay, fluid flowing from this end to this end, or from leading edge to the trailing edge with the pre-stream temperature T infinity. The fluid which is flowing, it may be liquid or it may be gases, understand, fluid which is flowing, which is at an initial temperature, that is the pre-stream temperature T infinity, understand, over the plate here, that one is, okay, this is called as a pre-stream temperature. If the plate is heating, understand, below this one is, this is the called as a plate here, and above the plate the fluid will be flowing, and fluid is flowing with the temperature T infinity, that is called as a pre-steam temperature. If the plate is heating from the bottom side, understand, here the temperature will be more, and here the temperature will be more, here the temperature goes on decreases if the fluid is moving, okay. If you take any distance from the surface to the above, temperature goes on decreases. Where the temperature is maximum, at the surface of the plate is the fluid temperature is maximum, understand, because of the heating is taking place here, understand. At the surface, the junction where the fluid is meeting with the contact surface, the temperature will be a maximum at this place. As the distance will be moving, understand, as the distance will be increasing vertically, the temperature goes on decreases, that one is, okay, goes on decreases. Where it approaches the mean stream temperature, okay, where it approaches the mean stream temperature of the fluid flow, understand, that distance is cut as a thermal boundary layer, understand, that distance is cut as a thermal boundary layer. What is the meaning of the thermal boundary layer? Thermal boundary, it is a vertical distance which is where from the surface, okay, is the vertical distances from the surfaces, where okay, from the surfaces where it approaches the means fluid temperature, approaches the mean pre-steam temperatures of the fluid, that is called as a thermal boundary layer. That one is okay. Thermal boundary layer is a region of a fluid flow near the solid surfaces where the fluid temperatures are directly influenced by heating or cooling from the surface wall. Understand? Okay. Simple concept here, that one is, here the heating will be taking place. Here the temperature of the fluid at the junctions of the plate and the fluid will be more. As the distance move, okay, as the distance move vertically, the temperature of the fluid will be goes on increases. At the point where the temperature of the fluid reaches the main pre-steam temperature of the fluid, that distance from the surface is called as a thermal boundary layer. That one is. Understand? That is a thermal. As the length increases, thermal boundary is also increases. Understand? Here the thermal boundary layer will be, so this is the delta T is called as a thermal boundary layer thickness. Here the thermal boundary layer will be increased different. Here, somewhere like that, the thermal boundary layer thickness goes on increases. That one is. Understand? Here the TS is called as the a surface temperature. Understand? Okay, surface temperature, that one is okay. So this is the concept of the thermal boundary layer, that one is. So here, for heat transfer, the boundary layer is known as thermal boundary layer, and its thickness can be defined as delta T. Understand? So delta T is called as a thermal boundary layer thickness, which is on the plate, can be defined as distance at which fluid attains 99% of the pre-steam temperature, are called as a thermal boundary layer thickness. That one is. Understand? Where it attains 99%, so where this is the flow where the fluid attains the 99% of the T infinity. Understand? Where the 99% of the fluid mainstream temperature, that one is. Understand? So that is called as a pre-steam temperature, which fluid attains the 99% of the pre-steam temperature. So that is thickness which is perpendicular from the surface, are called as a thermal boundary layer thickness. The thickness of the thermal boundary layer increases in the flow direction. Very, very important, that one is. Okay, in the flow direction. This is the flow direction. Understand? From left to right. The thickness of the boundary layer, okay, boundary layer, thermal boundary layer is increases in the flow direction. Understand? Okay, so this is the way that here the thickness will be different. Here the thickness will be different. Here the thickness will be different. That one is. Okay, so thickness of the thermal boundary layer increases in the flow directions since the effect of heat transfer are felt at a greater distance from the surface further downstream. That is. The fluid velocity, understand, will have a strong influences on the temperature profile. Okay, what I discussed in the fluid, okay, velocity in the previous slide. The velocity in the post convection, you know that one is, the fluid velocity will have a strong influences on the temperature profile. Post convection, the heat transfer rate will be much. Why? Because of the velocity will increase with the external agency, that one is. Hence, the temperature variation along with the velocity of the fluid flow. Understand? That's why I'm telling that the fluid velocity will have a strong influences on the temperature profile. The development of the velocity boundary layer, boundary layer will have a strong effect on the convection heat transfer. That is mainly in case of the post-convection heat transfer, that one is. Okay, so that one is the main thing, that one is the thickness of the boundary layer will be increases in the flow direction, and velocity of the flow will have a strong influences on the temperature profile. Hence, the development of the velocity boundary layer relative to the thermal boundary layer will have a strong effect on the convection heat transfer here that is. Okay, so this is the what is called as the thermal boundary layer that is. Here, any doubt in the velocity boundary layer, thermal boundary layer thickness, velocity boundary layer thickness, and boundary layer concept of the boundary layer? Hello?
Yes, sir.
Do you have any doubt regarding this one?
No, sir.
Yes. Sir. Here, next one, we're going to discuss about that what is called as the uh, uh, energy thickness in the boundary layer that is. Understand what is the energy thickness in the boundary layer? So we'll discuss this concept only, and we'll wind up that one. What is the this definitions is very important. Understand what is the thermal boundary layer thickness with a graphical representation of the